The Internet of Things is changing our lives with numerous applications across every industry, including energy, automotive, consumer electronics, and healthcare. Companies creating innovative IoT devices benefit from a broad range of ANSYS products. In this video, I'll discuss some interesting IoT applications and how ANSYS simulation tools allow engineers to understand how their products operate before being fabricated in the real world. We begin with a smartwatch that uses ANSYS tools in every stage of the design process. A smartwatch can monitor your health by measuring your blood pressure, pulse rate, and exercise performance. It can link to the internet, stream music to Bluetooth speakers, and display functions on an LCD. Successful design must address several issues related to electronics, control systems, and reliability. A key element is wireless connectivity. Omnidirectional antennas can be created and solved using HFSS to predict their behavior in their operating environment. Solving the antenna in HFSS generates input impedance that will tell how well your antenna is matched to internal circuits. You can also view radiation patterns in both the near and far field. The antenna is fabricated using a flex circuit and needs to be wrapped around the curved wristband. This introduces stress, causing potential design failure. With ANSYS Mechanical, you can simulate the stress and adjust it to avoid failures. In addition to the antenna performance, we need to look at the electronics within the smartwatch. Using ANSYS Electronics Desktop, you can perform analysis from IC to package to printed circuit board. ANSYS Apache tools like RedHawk are used for the IC modeling, and we couple those results with electromagnetics and circuit simulation to analyze the full system. As you vary the signal speed, you can determine the robustness of the design. The watch must not get too hot, and simulation can be used to predict the operating temperature. Here you see an electromagnetic analysis of the board coupled to steady-state thermal analysis to ensure that excessive heating is avoided. What's more, you can test the performance of your IoT device in a realistic environment. Here you see the wristband added to a human body model. A Bluetooth speaker was also added to model a receiver and the performance of the antenna in the vicinity of other electronic devices. The simulation includes the entire room to test the performance of the wristband under realistic electronic environments. Another complex electromagnetic environment is the modern automobile. The automobile industry is getting a real makeover, with major automakers envisioning a future of completely self-driving cars. Many ANSYS technologies will contribute to these vehicles as they are developed over the next few years. These include sensors, controls, touchscreens, wireless internet connectivity, electrical powertrain, and embedded software. Safety is a primary concern. In concept cars, technological features are guided by a combination of stereo cameras, radar, and proximity sensors. Automatic pedestrian detection capabilities are being developed using various sensing technologies like microwave radar, laser scanners, and computer vision. Using simulations by ANSYS tools to evaluate the performance of onboard radar is critical before real-world testing scenarios are performed. Cars are being equipped with large touchscreen panels for vehicle control and internet connectivity. These touchscreen interfaces need to be intuitive and highly sensitive to touch. ANSYS Q3D Extractor is used across the industry to design and simulate touch panels for capacitance, sensitivity, and robustness. The touch panel connects with other electronic systems, including complex mixed-signal circuit boards. They can even interface and keep you connected with home automation devices, sensors, and smart home products that add up to a rapidly growing number of things in the IoT world. A new product in our portfolio called ANSYS Savant allows engineers to solve extremely large antenna simulations by leveraging asymptotic methods. We combine the power of the full-wave solver of HFSS with hybrid methods and Savant's shooting and bouncing rate technique to solve models that are tens of wavelengths to thousands of wavelengths in size. The final area that I will describe is connected healthcare. ANSYS is working with ISS in Switzerland to assist eye surgeons plan the best procedures for corrective eye surgery. The tool you see here is a custom app called OptimEyes. It utilizes the ANSYS mechanical solver engine behind the scenes to perform necessary calculations for surgery planning. Traditional treatment for astigmatism uses small, relaxing incisions in the steep axis of the cornea. Because the treatment is planned based on statistics of typical patients, the outcome is good, but not optimal for the specific patient's eye shape. The surgical outcome can be greatly improved if surgeons could plan the surgery with patient-specific modeling based on ANSYS finite elements. The challenge is to create an application that provides the user interface that eye surgeons use and understand without needing to become experts at finite element analysis. ISS worked with ANSYS to create an internet-enabled system where the optimized app is operated at the surgeon's clinic. The secure, anonymized network connection links the app with a high-performance, centralized finite element simulator at ISS. Data is encrypted and password protected for security. The process uses standard imaging devices at the clinic to measure the patient's cornea geometry. That information is entered into Optimize. The surgeon then applies the proposed surgical cut characteristics in the app. Simulation is launched on the remote server, then predicted surgical outcome results are analyzed to find expected vision quality. Note that the process allows the surgeon to place virtual cuts and vary the location, extent, angle, and depth. IoT is set to transform life, business, and the global economy now and in the years to come. With so much opportunity, simulation-driven design tools from ANSYS become critical for engineers, empowering them to create the Internet of Things and make products reliable, inexpensive, and energy efficient. A connected life opens up a world of opportunities for everyone. Thanks for watching.